by omega. Okay. Angular velocity that is denoted by omega. Okay. And omega equals to. Now you tell first. How can we write linear velocity? Linear velocity that is called v, and v equals to change in displacement upon change in time. I told v equals to ds by dt. Okay, and that ds is called change in displacement. Am I correct? Upon total time. Total time or net time. Okay, change in displacement upon total time or net time. Here also tell omega, that is also velocity, but that is in linear angular velocity. So in case of omega, we can write change in angular displacement here. And what is this? Change in linear displacement. That is a change in linear displacement upon total time. And what is ds? Change in linear displacement. Here, what is omega? That is a change in angular displacement upon total time. Okay. So, how can you write change in angular displacement? That will be called delta theta upon delta t. Delta theta upon delta t. Okay. Next, what is the SI unit of this omega? SI unit. Here tell what is the unit of this velocity? Meter per second. Here, what is the SI unit of this omega? Tell me, what is the unit of this theta? Radian. And upon t is second. So, radian per seconds. Here we can write radian per second. That is the SI unit of this omega. Correct? And you tell that omega is a vector quantity or scalar quantity? Omega, vector quantity. It means here in this case also, how can we denote that what is the direction of this omega? Direction of omega. In case of linear displacement, okay, linear motion I am writing. I told already there are 3-4 types of equation. First is v equals to u plus at. Here second is s equals to ut plus half a t square. And what is the next? V square equals to u square plus 2s. In case of angular motion, like suppose your particle is moving along circular path. Here also some equation present. So I am writing for circular motion. Okay. So here omega. What is v here then?
V ds by dt.
V is linear velocity or angular velocity?
Linear velocity.
That is final or initial? Final. And that is also
Final.
initial. And that is also linear velocity. So we can write v, that is omega final equals to omega initial plus alpha into t. I will tell alpha. What is alpha? That is angular acceleration. Okay, I will tell wait. Just keep in this mind that alpha is acceleration, but when in case of angular angle. And what is omega final? Final angular velocity. And that is initial angular velocity. And that alpha is angular acceleration into time. That is first equation. Next see here. What is S still? S is displacement, linear displacement. Here I will write angular displacement. That is called theta. Equals to u. In place of u, we can write omega initial. ut. What may want? Constancy. S what? Linear displacement. Here I will write angular displacement. What is u? Initial velocity. What is omega initial? Initial angular velocity. That initial angular velocity. And what is t? T. Half. Right here 1 by 2 into. In place of a, we have to write alpha. Alpha into t square. That is second equation. Third here. What is written? V is
Omega final.
omega final square. Okay. Omega final square equals to omega initial square plus 2 into
Alpha. Theta.
theta. Because here is now in place of s theta. That is third equation. So generally in our circular motion we have to remember these three equations. Okay. V average equals to delta S upon delta T. Okay, and what about V instantaneous? ds by dt. Okay, similarly, omega average, what is value? Delta theta by delta t. And omega instantaneous, that will be d theta by dt. You know one thing, what is difference between average and instantaneous? Instantaneous means for one instant. Okay, it means at suppose your delta t tending to 0 means difference very small, tending to 0 very small. So we can now use this instantaneous value. Okay, so write one question. Theta equals to plus 2. So find
What is that question, sir?
that is variable or constant?
Variable.
Because it depends on time now. Time. So in first question we have to calculate omega in 2 seconds. And second add 2 seconds. Add 2 seconds it is instantaneous. Add 2. Instantaneous or average? Instantaneous. Right? I suppose I am telling we have to calculate omega. Add 2 seconds. Add 1 second. That's time fixed now. Add 1 instant now. That is instant. So that omega is instantaneous or average? Instantaneous. Now this will be average. Okay. So first I want to solve this question number 2. Okay. Question number 2. Here tell that is omega instantaneous or average? Instantaneous. Because given add t equals to 2 seconds. At instant it is asking. At instant, 1 instant. So I want to write here omega instantaneous, that is equals to ds by dt. But here I will use d theta. D theta because that is angular velocity, so angular displacement. Now tell d theta upon dt. I know theta is variable, so in place of theta we can write 2t square plus 2 upon dt. Okay, so that will be equals to, see here,